Okay, starting lesson 4 again in 3, 2, 1. Hello again, and welcome to another lesson on flipped learning. We're still on the chapter of algebra and linear equations, and today we're going to be looking at the subtopic of adding and subtracting fractions. Now, in my opinion, this is probably one of the hardest parts of this chapter, which, if you have a look at the schedule on the front of your booklet, is the reason why we're spending a couple of lessons dealing with this particular topic. It seems like that over the years, some people get confused with the methods for adding and subtracting fractions, but also multiplying and dividing fractions. Not only that, because we are working with pronumerals on both the numerator and the denominator, some people can get confused with how to work them out from there as well. So hopefully, using a couple of simple normal fractions in the different methods, we can figure out a way of getting rid of the cobwebs, dusting out the cobwebs, and remembering how to deal with our fractions. So let's get into it. With adding and subtracting fractions, you need to remember the following. For each question, we need to find the lowest common denominator, that is integral, before we start solving. The next thing is when we merge our fractions, once we've found a common denominator, we do not add the denominators together. For example, if I had two denominators which had a common denominator of 4, we don't add them together to give them 8. What does happen is it simply just has a denominator of 4. The only thing we do is add our numerators together to give us an answer of 3 in this case. Now, once we get to our final answer, the most important step is to make sure that we have simplified the numerator. Now, I'll introduce you to a couple of methods. It's up to you if you would like to use either of them. If you have your own that works, just make sure you check your final answer with what's been put on the screen to check that you have the correct answer. And also, make sure that if you have your own method, or at the end of this video you still can't grasp one of the two that I've given you, that you come and see me and we'll try and sort something out when we're in class. Alright, so method 1. Let's just take the example of, say, 1 over 5, and we are adding the fraction 1 over 8. Now currently we can't add them together because the denominators are not the same. But what we can do is to think, what value does both 5 go into, but also 8? That's why it's called a common denominator, a number that both 5 and 8 are divisible or multiply into. Now, if we think about it, if we go through our times tables, the only number that both of these go into is the number 40. So what we do then is we change our fractions to now have a denominator of 40, and we think to ourselves, all right, our left-hand fraction over there used to have a denominator of 5, but now it's changed to be 40. How did that happen? Well, what we did was we multiplied it by a factor of 8. But what we do to the bottom, we must also do to the top. So our 1 needs to be multiplied by 8, and that will get written on the top. Same goes for our right-hand fraction. It used to be 8 on the bottom, but now it's 40. How did that change between our two fractions? Well, what I did was I multiplied this one by 5. And the same goes for the top. Multiply this by 5. So now my fraction is 8 over 40 and 5 over 40. So our final answer is going to be 13 over 40. And I'll check that. It's simplified. I can't go any further. So this is our final answer. So that's method 1. Method 2 is, in my opinion, my favorite and the easiest, but again, that's completely up to you and how you learn. So having a look at the second method, let's do the same example. So 1 over 5, and we are going to add 1 over 8. Now the first thing we do in this method is multiply these two numbers together, and that will give us our common denominator. So 5 times 8 is 40. And you'll notice that if we go back to method 1, that's the same denominator that we found over there. Now that is just a coincidence. Some cases you are going to get a denominator that is higher than the people that worked it out in method 1. You won't get the wrong answer, but when you get down to this step here, you need to make sure that you have simplified it as like to its absolute smallest fraction. If you haven't, you will get marked down because you haven't simplified it. So yes, method 2 will require you in some cases to do an extra step, but if you learn how to do it, it can't go wrong. Alright, so once we've got our common denominator, we now multiply the bottom right denominator with the top right numerator. So 8 times 1 is 8. Then we take this mathematical operation here and put it in the middle, plus, and then we do the opposite. We do 5 and we multiply it by the 1 up here, so 8 times 5, and then we simplify. 8 plus 5 is 13, and our denominator is still 40, and we've got the same answer. Now during the examples on the next page, I will be showing you how to do them using this method. If you prefer the other one, I don't have time to do both, but if you use method 1, just make sure, like I said before, that you check your answer and matching it with the one that we've got on screen. And again, if you have any questions, make sure you come and check it out in class the next day. Alright, so moving on to example 1. So, the first thing we need to do, using the method described earlier, is to get our common denominator, is to multiply our bottom two figures together. So 3 times 2, which gives us now a denominator of 6. Alright, now what we need to do is multiply our bottom right by top left. So 2 times 2a is 4a. Then we multiply the bottom left by the top right. 3 times a is 3a. And don't forget to put the operation in the middle. Alright, now we can write our final answer. 4a minus 3a is a, and our denominator is still 6. Is this simplified? Yes, so this is our final answer. Alright, moving on to the next question. First step, multiply our denominators together. So 4 times 5 gives us a denominator now of 20. Alright, now jumping across, multiplying our bottom right by the top left, we get 5 bracket m minus 3, and then the next one is going to be 4 times m plus 7. Alright, when we multiply those brackets out, we are going to get 5m minus 15 and 4m plus 28. Alright, now if you remember back to a couple of exercises, we now need to expand our brackets. Not expand our brackets, sorry, combine our like terms. So 5m plus 4m is 9m, and minus 15 plus 28 is plus 13, and that's still over 20. And that's our final answer. Alright, moving on to the next example. This is going to be a little bit tricky because we have pronumerals on the bottom, but if you follow the example and we simplify completely, we're always going to get the right answer. So, 3x times 2x gives us our denominator of 6x squared, because x times x is x squared. Alright, now we do 3x times 3 is 9x, and 2x times 1 is 2x. Don't forget to put the minus sign in between there. So that gives us an answer of 7x over 6x squared. Now remember, I said the last thing you need to do is to check to see whether this has been completely simplified. And we'll notice that there's pronumerals on the top and bottom, so we need to cancel them out so that we've fully simplified our fraction. So there's 1 up here, and we'll get rid of 1 down here, leaving 1 left over. So our final answer is going to be 7 over 6x. Remember, the last thing you need to do is check to make sure your fraction has been completely simplified. Okay, now this question is going to be tricky, but we have done a couple of these last year in our chapter on products and factors. Now remember, in each of these previous examples, the first thing that we did was multiply the two denominators together, and that's exactly what we're going to do here. So our new fraction is going to be w plus 1 multiplied by w plus 3. Now at this point, don't expand them. We don't need to expand these brackets out. This is just showing that our common denominator is these two guys multiplied together. Okay, using the same method, we then multiply these two together. So that's w plus 3, w plus 2, and then we're going to subtract these two multiplied together. So w plus 1 and 3w minus 4. Now, like it said in the remember section, we are going to expand and simplify the numerator, but not the denominator. Okay, let's multiply these out. So the top, w times w is w squared using the wave method. Then w times 2 is 2w. Then 3 times w is 3w. So altogether we have 5w. And then 3 times 2 is 6. And we are going to be subtracting this other multiplication. So w times 3w is 3w squared. Then w times minus 4 is minus 4w. Then we have plus 3w here. So that's going to be minus, not plus, minus 1w minus 4 plus 3. And then finally, plus 1 minus 4 is going to be minus 4. And the denominator is just going to be the same. Alright, one last step to simplify. We're going to subtract these two guys from each other. So remember, we can do our like terms now. So here's w squared and 3w squared. We then have, if we let the computer catch up, 5w plus 5w and then minus w here. And then finally, 6 and minus 4. Now don't forget, each of these mathematical operations are still in play, and we need to remember of the minus sign that's in between. Okay, so let's do w squared, take away 3w squared, so that's minus 2w squared, 5w, take away minus 1w, so two negatives, remember, mean we add, so 5 plus 1 is 6, and then finally the numbers 6 take away minus 4, so again two negatives make a plus to give 10, and that's just on the same denominator. And that's it. We've covered adding and subtracting. Remember, if you have any troubles, to come and see me in class and we'll sort it out from there. I hope you've enjoyed this particular flipped lesson, and we'll see you in class soon.